Dear students, now we are going to study what area is and how we can find area of different closed figures on a plane. First, discuss what area is. Area means how much a closed figure occupies space on a plane. This is a plane. Suppose this is a triangle. And how much space does it occupy on this plane? Suppose this is a circle. How much space does this circle occupy on this plane? So this is area, and SI unit of area is meter square. Why meter square? In ancient time, people generally measure the area of different figures by taking a unit length, an equal unit length of a length and a breadth. Okay, it may be 1 centimeter of a square or even 1 meter of a square. Okay, now by using the area, we can find that the area of a square is, suppose, of 1 meter of length and 1 meter of breadth, then it will be 1 meter square. In case of a rectangle, how much square it will be? How much square meter will it be if we keep this unit length around it? Like this, we will find that if we measure different squares, unit square around it, we will find that a certain number of square tiles we can put here, and like that we can also put certain amount of square tiles around it. Suppose it consists on the length 1, 2, 3, 4 meter, and here it will be 1, 2, 3, 4, 5, 6. It will be 6 meter. Then the area of a rectangle will be 6 into 4 is equal to 24 meter square. So we conclude that area of a rectangle is length into breadth. Now we are going to study about area of a parallelogram. Here I have a parallelogram. In this parallelogram, this is base and this is height. I just cut it and make it rectangle. The area of this closed figure will be equal to area of this closed figure because this occupies same space as it earlier occupied the space. Thus this triangle is cut off from here and just added here. So it forms a rectangle of length this much and breadth this much. So area of this rectangle is length into breadth. When I just cut these pieces and join here, it forms a parallelogram. So its area will be this much as it was here. This portion is cut and added, and this portion is also cut and added here. So there will not be any change in the base. And its height here will be this much as it was the height then of this rectangle. So area of the rectangle is length into breadth. Like that, the area of a parallelogram is base into its corresponding height. So area of the parallelogram is equal to a base into its corresponding height. As like as we find the area of a rectangle exactly as like as in parallelogram. Now, here is also a parallelogram. Here is also a parallelogram. In this parallelogram, we find that it becomes two congruent triangles diagonally. You know it well that diagonal of a parallelogram divide a parallelogram into two congruent triangles. So when I make this form a parallelogram. So area of this triangle will be half of the area of the parallelogram. So area of a triangle is exactly half of area of parallelogram. Means half into base into height. Let's take another example. Here I have a rectangle. When I cut it into diagonal into two congruent triangles, it will be equal to the area of half of the triangle formed. Thus, the area of a triangle is half into base into height. If it is a right angle triangle, the area of this triangle is base and this is the height. So half into its base into its height. Height is its own side.